Welcome all. In this video we are going to talk about the glucose preparation and its structure. Okay, glucose is a monosaccharides. Monosaccharides means you know that it cannot be hydrolyzed further. Okay, it's a monosaccharide, contain only one unit of one unit. So it is an aldohexose. Aldohexose means it contains aldehyde groups. So glucose is also known as a dextrose. So another name for glucose is dextrose. So why it is called as dextrose? It is dextrorotatory in nature. In your lower classes you might have studied that some organic compound can rotate the plane polarized right. So if a compound rotates the plane polarized light towards the right, it is called as a dextrorotatory compound. So glucose is a dextrorotatory isomer. So where it is found, it is also called as a grape sugar because it is found in most sweet fruits, especially grapes. So it is called as a grape sugar. So it is found in grapes. It is also present in honey. Okay, honey also contains some glucose. Actually, glucose will be formed in our body by the breakdown of the food we eat also. Okay, for instant energy also we take glucose. Okay, how the glucose is prepared? Probably in the laboratory or for our use. So it is prepared from sucrose. Sucrose is a disaccharide. Okay, in the lab it is prepared in the from the sucrose. Sucrose is a disaccharide. So when powdered cane sugar, that is sucrose, is heated with concentrated alcoholic solution of HCl. Okay, concentrated alcoholic solution of HCl. HCl is dissolved in alcohol for around 2 hours at 323 Kelvin, around 50 degrees Celsius. So the glucose is formed. This is the reaction. C12H22O11 is the sucrose. Okay, with water. The HCl, concentrated alcoholic solution of HCl, will contain water present in a small quantity, which hydrolyze into glucose and fructose. So we will be getting glucose and fructose because sucrose is made up of glucose and fructose. Okay, sucrose is a disaccharide. It is made up of glucose and fructose. When you hydrolyze the sucrose, you will get glucose and fructose. So glucose and fructose from the hydrolysis can be separated. Okay, glucose is insoluble in alcohol, while fructose is soluble in alcohol. Hence, glucose can be crystallized first, leaving fructose in the solution. So glucose can be filtered off. Okay. So for crystallization, a few crystals of glucose is added. That's normally called as seeding. That's called as seeding. Okay. So purification of the prepared glucose is done by recrystallizing in the methanol. Recrystallizing means dissolving in methanol under a hot condition and then cooling down slowly, so the glucose get recrystalled. Okay, next another method of preparation is from starch. That is a commercial method. Last method we saw is a laboratory method. So this is the commercial method. So starch on hydrolysis with sulfuric acid under 3 to 5 atmospheric pressure gives glucose. So this is the formula for the glucose. Here it should be C6H10O5. It is not C5. It should be C6H10O5. It's a typo error. So you will get C6H12O6 when it's hydrolyzed with water. Okay. So when the hydrolysis is complete, the excess of unreacted sulfuric acid is neutralized with calcium carbonate and it is filtered off. So the filter will contain calcium sulfate. Okay, filtrate which contains glucose, normally it will be having some impurities. So it will be decolorized using animal charcoal, that is carbon. Animal charcoal which absorbs most of the impurities. So the clear solution is evaporated in vacuum to get a thick syrup from which the glucose can be crystallized by cooling. Okay, so this is the second method of preparation of glucose. We are going to talk about the structural elucidation of glucose. Okay, structural elucidation. What is the structure of glucose? Okay, we are going to cover only the major points, not all the points, only the major points for the structure of glucose. So elemental analysis is a technique called as elemental analysis, which gives how much amount of carbon is present, how much amount of hydrogen is present, and how much amount of oxygen is present. And the molecular weight determination shows that the formula is C6H12O6. So the formula for glucose is found out to be C6H12O6. So complete reduction of glucose with concentrated hydroiodic acid, HI, okay, concentrated hydroiodic acid, in presence of a catalyst red phosphorus will produce N-hexane as the major product. So which shows that the glucose contains 6 carbon in a chain. Okay, unbranched 6 carbon because it gives the N-hexane. So N-hexane does not have a branch, so glucose does not have a branch. So basically this is the reaction of glucose with HI. This reaction is also we have to discuss in the properties of the glucose also. Okay, with HI it gives N-hexane. It's also a chemical property of the glucose. When you are going to study the chemical property, this reaction, the reaction which we are seeing, has to be included in the chemical property of the glucose also. Okay, next is glucose readily dissolves in water to give a neutral solution. So which means that it does not have an acid or a basic group. Okay, which means that it does not have a carbonyl group. So it indicates that it does not have a carbonyl group. It reacts with hydroxylamine to form an oxime, monooxime. So only one oxime is formed, which indicates that it consists of only one carbonyl group, not a 2 or 3 carbonyl group, and it also adds with 1 mole of HCN. So which indicates presence of either aldehyde or ketone, because both these groups can react with hydroxylamine and HCl. So these groups are normally called as carbonyl groups. So with HCN and with hydroxylamine, it reacts with only one product. This is the reaction. So with only, so this structure we are considering after I think after we know the structure. So we are just illustrating the property. So when glucose reacts with NH2OH, so this is the reaction that is taking place. So here we have shown the aldehyde, so which we found out after all the studies. So which we are discussing for simplicity to understand the concept. So with HCN, so it forms hydroxyl, it forms cyanohydrine. Okay, with NH2OH it forms that is NH2OH is the hydroxylamine. It forms an oxime, glucose oxime. With HCN it forms a cyanohydrine, glucose cyanohydrine. Okay, next is on mild oxidation. Mild oxidation, the oxidizing agent, as you know, there can be a strong oxidizing agent, there can be a mild oxidizing agent. With a mild oxidizing agent like bromine, glucose gives gluconic acid. This the CHO is oxidized to COOH. Okay, this indicates the presence of an aldehyde groups, because aldehyde groups can be easily oxidized to an acid, while a keto group it needs a stronger reagent to get oxidized. Okay, actually glucose also, next property we are going to see glucose also reduces tolerance and the fillings. Okay, so this is the reaction with bromine. It gives gluconic acid. The action of bromine with glucose gives gluconic acid. So CHO is oxidized to COOH. Okay, oxidation of glucose, that's a strong oxidation agent. Next one is we are going to oxidize the glucose in presence of a strong oxidizing agent like nitric acid. So oxidation of a glucose with a strong oxidizing agent like nitric acid gives saccharic acid. So this indicates that there is a primary alcohol group present. Okay, primary alcohol groups with a stronger oxidizing agent gives an carboxylic acid. So this is the reaction. So the CHO is of course is oxidized to COH, and the CH2OH, this is a primary alcohol group. Primary alcohol means the carbon is attached to only one carbon. So this is oxidized to saccharic acid. So glucose reduces tolerance reagent. Tolerance reagent is nothing but an ammonical silver nitrate solution. So which can act as a mild oxidizing agent. The silver nitrate gets reduced to silver, and a cupric filling solution, that is sodium potassium tartrate, that is fillings B, and copper sulfate, that is fillings A. When they mix together, So it's called as a filling solution. So filling solution is reduced to red cuprous oxide. Glucose gets oxidized. Okay, basically filling solution is a mild oxidation agent. So this further confirms the presence of aldehyde groups. So the tolerance reagent, ammonical silver nitrate, is reduced to silver. Okay, see the CHO is oxidized to COH. CHO is oxidized to COH. CH2OH is not oxidized because tolerance is a weak oxidizing agent. So silver is formed, and also here also you will see glucose goes into an gluconic acid, not saccharic acid. Saccharic acid is formed with nitric acid. This is gluconic acid. Okay, and Cu2, Cu plus, that is red precipitate. Okay, so glucose, this is an interesting reaction, reacts with an acidic anhydride in presence of Zil chloride to form pentaacetate. So normally an acid derivative reacts with an alcohol to form an the ester. So since it reacts with the 5 acidic anhydride, this is an acid derivative, acidic anhydride. Instead of acetic acid, we are using acidic anhydride because acetic anhydride is little bit reactive. So which shows that there is a presence of 5 OH group, which consists of 5 OH group. So this is the 5 OH group which we are representing. So this is the pentaacetate derivative, glucose pentaacetate derivative. Okay, so with the above evidence, we say that it's an aldehexose. So the formula is the first carbon there is a CHO and the second carbon CHOH, and there is a lots of other experiments which we are not showing for the sake of simplicity. We are only discussing the main points to get the structure of the glucose. So you have to remember that in the third carbon the OH is the left hand side and the H in the right hand side. So there will be 5 OH groups. Okay, these are this 1, 2, 3, 4. The 4 carbons are optically active. Okay, and there is an aldehyde and there is an alcohol which can form an acetal. Next one we are going to talk about the cyclic structure, because the CHO and OH in the 5th carbon forms an hemiacetal. Okay, that's a property of an CHO. That is aldehyde groups. Aldehydes with an alcohol, with one alcohol form an hemiacetal, with 2 alcohols form an acetal. Say 6-member ring is formed because 6-member ring is more stable than the other 5-membered or 7-member rings due to that bond angle. We say it as a torsional strain and torsional angle in chemical terms. So 6-member is more stable. So this is the cyclic structure of the glucose. See over here, when the OH in the right hand side, it is called as an alpha D glucose, and when the OH in the left hand side is called as an beta D glucose. Okay, this is the basic points that reveals the structure of the glucose. Okay, with this we end this video. We will meet again in the next video with the properties of glucose. Thanks for watching. Bye.